Hey everyone, this video is about app services. But before we dive in for demos, let's talk a little bit about how running in the cloud is different from running in your data center or on-prem. We'll start with on-prem. In this case, your company does everything from buying the hardware to patching the OS. This is the most costly scenario because the employees of the company are responsible for running and monitoring everything. Imagine here what happens when there's a leaked credential or someone gains physical access to the servers. But even when nothing bad happens, there are lots and lots of moving parts that need to be paid attention to. When you add up all the tasks, it's obvious why this is costly. The positive and negative in on-prem is that IT can control everything. This leads us to our first step into Azure, Infrastructure as a Service, or IaaS. Here, Azure leases a virtualized OS for you. For IT, there's a lot less work and less expensive than on-prem because many responsibilities are shifted to the Azure data centers. Not only that, but it also adds significant security hardening and the ability for automation to help manage everything. It is still your responsibility to patch it and manage everything. This is a major step for many organizations and is known as lift and shift. Typical IaaS building blocks are VMs, managed disks, load balancers, firewalls, and so on. This leads us to the next level of offering called Platform as a Service, or PaaS. These services drastically reduce IT responsibility. They are born and designed to be operated in the cloud and so have broad capabilities across the 5 modernization pillars of security, performance, reliability, operations, and cost. Application developers finally get helpful building blocks because these services are targeted to common dev scenarios. Popular PaaS services include App Service, Azure AD, Key Vault, APIM, to name a few. Finally, moving to the right, Software as a Service, or SaaS, is the final type of offering. Think GitHub or Office 365 here. Companies sign up to complete solutions. But today we're going to talk about App Service, and that's squarely in the PaaS pillar. App Service is used to host websites and APIs. Everything below the web service is operated by Azure while providing an uptime SLA of 99.95% uptime, along with other useful features. I'm going to call out 5 of these: a large number of languages, network integration, autoscale, deployment slots, and AD integration. So why is autoscale important? Every web application consumes some resources before responding to requests. No matter what platform you use, there will always be a limit to how much load it can handle. It might be 30 requests a second or 1,000, but there's still a limit. And that's where autoscale comes in. You pick a representative measurement and you use that to set up autoscale rules. The best way to illustrate this is with an example. Here, when the average CPU is greater than 70% for 10 minutes, the action would be to scale up by 1 instance. If the built-in measurements are not adequate, there are ways to use other measures as well. Many organizations scale websites to handle the max load, but with autoscale, it adapts to the incoming request load. When the time is right, it will also scale the resources back down, which will minimize costs over a long period of time. Another scenario is deployment slots. Most websites have something specific that they're monetizing. This could be ads, or it could be customer loyalty. However, once customers recognize that they are monetizing, they are reluctant to make random changes to the website. They get locked into that same version. Deployment slots remove this problem. They allow you to segregate your traffic into multiple code bases. This concept has many names: A/B testing, champion challenger, or blue-green deployments, to name a few. You can measure the monetization of each slot independently to see how each scenario performs. Once you find a scenario that is effective, you can continue to put more load on it. This step-by-step approach is extremely effective for production traffic updates and removes the handcuffs that monetization adds. Another way to use deployment slots is to assign different DNS names to the slots. This allows you to stage your workload, test it, and then when the time is right, you can flip the switch and promote stage to production. For languages, App Service runs code bases from a variety of languages and frameworks. This makes it very useful because it supports so many different platforms, especially the container scenario. Watch for a future video where I demo deploying containers. For now, we'll demo 2 of these languages in a short while. Let's talk about identity and network next. Maybe the best part of app services is the variety of options for integration. On the inbound side, you can set up an ACL, which can be used to limit access to known networks. You can also add AD integration, which means that every request would need to be authenticated in order to connect to the website. This is a great option for B2C and B2B, where you offload the authentication to Azure Active Directory. On the outbound side, you can integrate the application into a network of your choice, just as you would on-prem. Depending on how much isolation you want, you can deploy your app service into an isolated instance or into a serverless option. Serverless doesn't really mean there's no server. It just means that there's some random server located somewhere. In the middle of these two, there are scenarios where you can integrate the app services outbound into your Azure VNet. Once in the VNet, you can use network security groups or managed identity to further control access. With all of these, the service also obeys any networking policies that have been deployed into the subscription. Okay, so there are a lot of ways to deploy the app service, but for now, let's move to our demo phase. This is the sample directory structure of a Python Flask application. We're going to deploy this application to the web and see it work. We're also going to deploy this C# application. This was created using .NET New Web App. .NET has a lot of built-in templates, so depending on your needs, you can pick the one that works for you. For our demo, we'll use the web app. Coding aside, there are two tasks for app service, creation and deployment. There are several options for both, depending on your preferred tooling. For our demo, we'll deploy using the command line. The AZ command line makes it easy because the same command is used to create or deploy. If the service does not exist, it'll get created, and if it has been created, the latest code will be deployed with this command. Okay, so now we're going to deploy two app services, one in Python and one in .NET. One thing to note, when you deploy the web app, you can use that command line, and you can specify the SKU. The F1 SKU, by the way, is free. And I think it's free in one instance per region. So for us, we're just going to deploy Python and .NET in two different regions, and that way we can use the F1 SKU for both. You also need to specify the operating system, and I'm going to specify Linux for both of these. But in general, when you deploy your application, one of the first things you want to do is to make sure that the language and runtime you're expecting to use is available in Azure. So we're just going to do AZ web app list runtimes. Here, these are the versions that are available in Windows, and looks like in Linux, there's a few more. The ones that we want, Python 3.7 and .NET Core 6.0, are both available, so that's good. Now, what we're going to do is we're going to deploy our application. Once you deploy it, one of the things that happens is that App Service creates a container listening on a particular port. I discovered that for Python, you need port 8000, and for .NET Core, 8080 works pretty well. You also need to specify the startup command. So let's go deploy our apps now. I have already done .NET New Web App here. And so let's go and deploy this. So we're going to use the command line. So here it's telling me that the app does not exist, and it's going to be creating it. While this is deploying, let's go switch over to the Python and deploy that. This is what I showed earlier. Now, one thing to note, my font makes it look like there's a single equal sign here, but there's actually two. So it's the same command, identical to what we did with C#. Same again, it doesn't exist, so it's going to create one. Let's fast forward until both of them are deployed now. Okay, so now that that has deployed, let's go and make the configuration setting. Oh, looks like both of them have deployed, C# and Python. Let's go to Python. So let's add the Flask run port here. And 8000. And then we're going to go to the general settings and set the startup command. Notice here that the minor and the major version that are available are listed here. Okay, with those, I'm going to save it. Both of those settings are needed in order to start up my application. Once that's saved, I'm going to restart the web app. Okay. So while that's restarting, now we're going to go into the C# one and do the same changes. First, let's change the port. .NET Core, we're listening on 8000. Let's set the startup command. That's that. Let's save this. Once it's saved, we're going to restart this application. Restart it. Okay, let's go take a look at our Python app. And there it says hello world. And let's go check out our C# version. And there, that's up as well. So that was the end of our demo. Keep your eyes open for the next version of it. We'll actually show you how you can debug some of these. So sometimes when you're deploying, there's always going to be some errors or whatnot, and you need to be able to know how to debug that. So I'll show that in the next version. Thank you, and please subscribe to the channel.